So hello guys, welcome again to Edule, and in the last topic we just discussed about one type of waves, that is longitudinal waves. Okay, so now we will be discussing about the transverse waves. These are just simple basic waves, and these are not much in this chapter of sound, but again we just wanted to discuss this type of waves too. So let's discuss what are transverse waves. If you remember, we said that in the longitudinal wave, if the motion of the wave is actually in this direction, okay, this is the motion. What do you say? Uh, Direction of the motion of the wave in which the motion is wave is actually propagating. Then what do you say? The particle motion is actually just parallel to it, isn't it? It's just parallel to it, as you can see. It's just parallel to it. Okay. Now, what is transverse wave is actually these are your particles. Let me just draw some stream of particles. Okay, if these are your particles of your medium, these are the particles of your medium, and your wave propagation is say in this direction. It's just like the same last time. As if a wave propagation is in the direction, what is going to happen that the particles are just gonna uh, what do you say, the motion of the particles will be to the right angle. In this case, in longitudinal case, it was, as you can see, uh, longitudinal case it was parallel, but in this case it is going to be right angle. That means if this is going to be your uh, direction of propagation of your wave, this is going to be the direction of your motion of the particle. So this is going to be a 90-degree angle. Okay, so how it's going to be formed? Okay, so if say one particle goes up, okay, so it is going to be like just like this. They're going to up and down. Okay, there first they will go up and they will go down. The next particle will go up, then it will go down. Then another particle will go up and it will come down, and same like this. Okay, they go and up down. That is form this kind of structure. As you can see, they form this kind of structure. They actually go just like it forms like if this is your say line of zero disturbance, or we should say zero distance. I mean, this is your, if your mean point that every particle is at this position, they will form this type of structure. Okay, what will happen is that if these are your particles, let me just make some bigger particles, and let me just make some bigger particles, and they are, let them be some farther apart. Okay, so what's going to happen is that if this particle rises up to this distance and it comes up back again, okay, this one goes up to say this distance and goes back like this. Actually, first they just we should not make this at this point. Let's just make this one. This one goes up again. This one goes again. So it is at this point. This is at this point. If this is at this point, when this happens in continuous motion, this type of wave is actually made, as you can see. This same type. That's why I imported this picture. The same type of wave is actually made, but the particles are just like this. Okay, wave will be traveling in this portion. Some particle just rises like this, some like this. Okay, and then some like again. It's gonna be uniform. It's not like the particle will rise to the same distance, but what is gonna happen if this is actually in continuous motion, what is gonna happen, it will form, the form is gonna be like this only. You will see it like this if you join this line. Okay, so that is how the particles are gonna move. It is right angles. Again, the later how exactly the particles move is will be described in higher classes. So we are not covering that one. Okay, so this is actually what do you say? Nothing but your actually how the transverse wave move. So say this is your line, if we say, because again we are not covering the graphical representation, guys. graphical representation of both the transverse wave and both the longitudinal wave is going to be in the next video, so do check that out too. So what is going to happen in this is that if this is your wave motion, same as like particle are just, if one particle is at this position, one is at this position, one is at this position, one is at this position. Okay, eventually both all of actually rising at to the same distance, but it actually looks like when we see it, what happens is that again by the continuous movement it looks like this. Okay, so that is what it looks like when they continuous. Now we are going to let's give some examples. Okay, so let me just clear all this. Okay, now let's clear all this. So let's give an example of a slinky. Let's not talk about slinky. Let's see the example of what you say if you a thread. Okay, so what happens if you just jerk a thread? If you jerk a thread, you know what is jerking? Jerking is like if this is here, you just if you take this point of the thread, if you first pull that point of thread up and then down or then okay, so if you just first pull it up, and then just drop it down with some energy power, so what happens, this type of wave, transverse wave, is gonna arise in which this type of pulse will be generated. Now there is a difference between a pulse and a wave. The main difference is that pulse is just a single disturbance in the medium. However, wave is actually a continuous disturbance with, as you can see, this is a continuous disturbance which takes place in a medium, and wave on the other hand, pulse is just a single disturbance that is not followed by any other, what do you say, pulse or sort of this another disturbance. It's just a single disturbance on your thread. This type of disturbances happen if you do this on a slinky, if you have heard of a slinky, this is gonna happen. Okay, so first example we can say is a slinky, or you can even jerk a thread. However, it's not gonna be a wave, but the, what do you say, the movement of particles is gonna be the same. Okay, so let's talk of another example. Another example is nothing but just what do you say, ripples in the water that you see. Ripples in water. Ripples in water. Ripples. Okay. Ripples. So if this is a, say, a water. Okay. This is a pond. Okay, and from here this is a water, and from here if you drop a stone at this point, what is gonna happen is that some sort of like these ripples are gonna created. Okay, so the question is, what are these ripples? Okay, if we take this as the surface of water, okay, this is your surface, this is again, this is the surface of water, this. Okay, and if the stone is just like dropped like this, what is gonna happen? The stone is gonna displace some amount of water, and then if this is the point where the stone was dropped, certain type of, as you can see, waves are gonna create, isn't it? Certain kind of waves are gonna create on the surface of water, and these waves are actually ripples on the waves are nothing else but they are actually, what you say, your transverse waves. Transverse waves. So that is only for this video of transverse waves. In the next video we will be having a look at the, what do you say, the graphical representation of the transverse waves and the longitudinal waves. So thank you for watching this video. If you have any queries or any doubts, please log on to our website edule.in, where all the doubts will be answered, and that too for free. Thank you for watching.